Hey, what's up, guys? My name is Saurav, and this is my YouTube channel, Data Science Novice. So, if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. In the last video, we talked about template matching and its use cases. Although it's not a great way to detect objects or faces, but it's a good entry point for object detections and it builds up the intuition for how object detection works in practice. And now slowly we are going toward learning things that can be applied in real world. And also in this video you will see that we have used our previous knowledge to get better result for contour detection. And in this video we will see what is contour, different parts of the contour, and how we can use contour to detect the mask on someone's face. Note that this topic is quite wide and I would suggest you to try to look into the documentation and try different things like drawing contour around the hand and all that thing. So what is contour? Contour can be explained simply as a curve joining all the continuous points having same color or intensity. So for example, we have this hand and you can see that green boundary around it that gives us a shape of hand, and this is known as drawing contour around the hand. And contours are very useful tool for shape analysis and object detection and recognition. For example, you can use it for detection of different traffic signboards, and there are many use cases of contour detection. So next we have this image, left side image. So you might ask, what is the purpose of this image? So if you have been following my video series, you might have guessed what is this image and that how we arrived at it. So it's a binary image and we get this image by applying thresholding. So for better contour detection, we use binary images. And in OpenCV, finding contour is like finding white objects from black background. So remember, object to be found should be white and background should be black. So next I would like to talk about the types of contour we have. So in an image, we can have many contours depending upon the types of thresholding we have done. So they can broadly classified into two categories, external and internal contours. Here we have this image which consists of perforated rectangle and a circle. And if we try to divide this image based on the types of contour, then we can have these two images. So the rectangle and circle is the image or external contour, and the circle inside the rectangle are considered as a internal contours. And in later part of the video, we will see that how can we grab internal external contours from the image. So if I now ask you how many contour it contains, and if you have guessed 7, you are absolutely right. So this is very useful in traffic sign detection because generally signs are inside a square or rectangle box. So we get two types of contours there. And then we can use our knowledge to grab the sign from the signboard. So next I would like to talk about different types of hierarchy in the image. So sometimes objects are in different location, but in some cases some shapes are inside other shape, just like nested figure, and we saw the example in the previous slide. So in this case we call the outer one as a parent and inner one as a child. This way contour in an image has a relationship to each other. And this idea can be extended to this image as well. So here we have multiple hierarchy. So blue is the parent of gray one, and in turns gray one is the parent of the yellow one. And also we can specify how one contour is connected to each other. Like is it a child of other contour or is it a parent, etc. etc. Representation of this relationship is called hierarchy. So that's all for the theory part from my side. And if you want to deep dive into this, there are many resources available out there. So let's jump to the Jupyter notebook and practice it. So I have already imported all the essential libraries and created a function that display the image. Next, I have uploaded the image as a grayscale image and then using thresholding converted this grayscale image into a binary image. And I have a separate video on how thresholding works. You can check out in the playlist. So let's run this cell. So this is the same image as we used in theory, and now we are going to see how we detected all these contours. And if you want to download this image, check out the link in the description. So to find the contour in the image, we just have to call cv2.findContours, and this takes couple of arguments. So first we pass the source image, next we pass cv2.rtr underscore ccom, and the last argument we have to pass is cv2.chain underscore approx underscore simple. And there are couple of parameters to choose from. So this function returns two things. First, it returns all the contours, and then it returns their hierarchy. So we create these two variables, contour and higher, short for hierarchy. So let's run this cell. So the second argument in this function retrieves all the contours and arrange them into two-level hierarchy, that is external and internal contours. And the third argument removes all the redundant point and compress the contour, thereby saving memory. So for example, we have a rectangular box, then we don't need all the points, we just need 4 points to draw the rectangle. Next, we see how many contours this method has detected, and we already know the answer, that is 7, and we are getting the 7. And the detected contours are 1 square, 5 small circle, and 1 big circle. Now let's look at the contours variable, that what we have in that. And here we have bunch of numpy arrays, and they are nothing just approximated coordinates or points, so we can draw them on some other images. So now let's look at the higher variable. So here we see an array and we will use it shortly, and we will grab external internal contour using these arrays. And let's look at the number of hierarchy we have. So here we have only one hierarchy, that is external and internal hierarchy. So now we are going to see how we can grab external internal contour from this image. So first we are going to create a black image. So black image equals to calling np.0, and then we pass image.shape because we are going to create image of the same shape. So here we are creating a black image on which we are going to draw the contours. So next we run a for loop to get all the contours. So for I in range, len, and then we pass contour variable. So we are going to run the loop for 7 times here. So next we are going to pass if condition. So if higher, then we do a little bit of indexing, that is 0, then on I, and finally on 3, and pass this condition equals to -1. So if you look at higher variable and see fourth column, it only contains 0 and -1. So this code is saying just grab external contours which are represented by -1. And then we draw them on the black image. So we call cv2.draw contours and we pass few arguments. So first we pass the image and then we pass the contour variable which has all the contours in it. Next we pass the ith variable. So basically we want to draw ith contour from the available contours. Next we pass the color and then we pass -1 to have a filled shape. So next we plot the image. So once we are out of the loop, we call image plot function and pass the image. And next we press shift enter to run this cell. So here we see that we have only two shapes, that is rectangle and the bigger circle, and we don't see inner circle in the rectangle. So this way we can grab external contours. Next we are going to grab internal contours. And the code for internal contours is going to be very similar. So we are going to copy paste the whole code and we just have to change the condition from -1 to 0. So let's do that. So here we can see that we have grabbed all the 5 smaller circle from the rectangle. So this way we can grab internal contour as well. Next we are going to use the knowledge of contour detection and use it to detect the mask on person face. So let's import the image, and the image link is in the description, although you can find it on internet very easily. So we pass the file name as maskman. Next we change the color channel from GBR to RGB. So cv2.cvt color, then we pass the image and then we pass the color channel conversion. And by now you should be familiar with this code because we have been using a lot in our code sections. And next we are going to plot this image. So we call our plotting function and pass this image. So here is the man wearing a blue color mask and the task is drawing contour around the mask. So first of all, we are going to change the color channel to HSVC, and it stands for hue, saturation and value. And it's just another way of expressing different color in the white light spectrum. In RGB, it is very difficult to find bright colors or dull colors, but that is not the case with HSVC. So here you can see that how image looks like. So our next task is to convert this image into binary image. So next we are going to define a range for blue color, and using this range we are going to convert this image into a binary image. So lower equals to np.array and we pass the value. And I found this value on internet and then trying some plus minus. And we are passing three values because it still has three color channels. So on similar lines, we are going to define a high variable and then we call np.arrays and we pass the value. And again, we don't have to memorize these numbers. You can find them on internet easily, even for some other color as well. And sorry for this cropped video, but you will see it eventually. So next we define a mask variable and then we call cv2.inRange function. And this function takes few parameters. So first we have to pass the image. So in this case, we are going to pass this HSVC image. Next we pass the lower and high variable that we have created. Okay, so we are getting an error. So it should be lower, not low. So let me correct it. So the in-range function will change the color of those pixels that comes in this range as a white and everything else a black. So we are in a way converting it into a binary image. So in a way it is doing the same thing as a thresholding. So let's see the image. So here you can see that it changes everything into black except for the mask because it was blue. So it goes through each pixel and check whether it falls under the defined range. And if it does, it change the pixel to white, else it change it to black. So next we are going to draw contour around this binary image. So we call the find function again. So it has already been talked about that how it does, what function it takes. And if you notice that it is going to detect a lot of contours because this mask has small dot in it. It's like the previous rectangular image we had. So first we pass the image and next we pass these parameter which I have already talked about. That is second parameter is going to extract all the contours and the third parameter will grab only important points of these detected contours. So now we are going to use the same image to draw on it. So let me copy paste the image and change the color channel to RGB so that we can see the image actually the way we see them. Next, we are going to create detected mask variable and we pass the draw contour function. And this time we don't need to run for loop because we are going to draw all the contours, that is external and internal contours. So to draw all the contours, we pass -1. Then we pass the color code. So we are going to draw green boundary around it. Next we pass the thickness of the boundary. So that's all we have to do. So now let's plot this image. So here we see that we are able to draw contour around the mask. And this is very naive way to detect the mask. And we will be implementing some state of the art algorithm in later part of the video series. And you can play around with these parameters like changing the color and the width like I am doing. So now we are going to see how can we detect the mask in real time or using webcam. And the code is going to be very similar of what we have been doing so far. So I'm directly going to write the code. So let me show you the code. So here is the whole code and if you don't know how to access camera and all, watch my video on video basic and I have explained everything there. As of now, I have commented out this line of code and we will see why and rest of the code is going to be same again. So first we capture the frame, we change the color, next we define the range and convert it into a binary image. Then we draw contour and run a for loop so that contours keep getting updated as the frame changes. So let's run this cell. So here you can see that I am wearing mask but we don't see any contour around it. But my jacket is dark blue so it is drawing contour around it. And next you can see that it is drawing contour around my head also. So maybe it is confusing the dark blue with black color. So as of now my mask is orange. So we don't see anything and even if I bring it closer to the camera, still we see nothing happening, right? But now if I turn it around, which is dark blue, so you can see it start drawing contour around the mask. And in the right side, we can see that the image is getting converted into binary image in real time. So whatever it perceive as a dark blue or black color, it start drawing contour around it. So let's try to improve it. So now let's bring in the blurring code into this block of code and see what changes. And next we have to pass blur image instead of frame. And that's all we have to do. So let's run this cell. And now we can see that we don't see that many contours. That is because we have made this image less detailed. So this way we can play around with video as well. So that's all for this video. And if you haven't subscribed to my YouTube channel, please do like and subscribe and make sure to hit the bell icon for the future update. So see you in the next video. Till then, bye, wear mask and stay safe.